All right, today we're going to talk about a book that makes some of the most audacious claims I think I've ever come across. It suggests that one single, simple idea could rewrite 2,000 years of science, crack the deepest mysteries in physics, and maybe even link science, philosophy, and theology all together. I know, it's a lot. So, let's get into it. And the whole thing really kicks off with this one question. What if the most basic building block in all of math, an idea we've just accepted as true since ancient Greece, is the very thing that's causing our most advanced theories of the universe to just break?
The book we're diving into is called The Rebellion of the Point. And yeah, you can tell right from the cover, they are not shy about their ambitions. I mean, they're claiming their theory could solve problems that stumped people like Einstein and Hawking, and that it's worth up to 5 Nobel Prizes. So what is this earth-shattering idea? Well, it all starts with a problem, the problem of infinity.
To really get what they're proposing, you first have to understand the problem they're trying to solve. And trust me, it's a big one. It's a problem about infinity that's been a thorn in the side of physics for about a century now.
This whole story really starts way back with the ancient Greek mathematician Euclid. He defined a point as something with no part, which basically means it has 0 size. It's not a physical thing, it's just a location in space. And that elegant, super simple definition became the foundation for everything: geometry, calculus, and eventually all of modern physics.
But here's the catch. When physicists tried to apply this zero-size idea to real particles, like an electron, their equations just went completely haywire. Suddenly the math says an electron has infinite energy. When particles bump into each other, you get more infinities. And then you have the center of a black hole, a singularity, which is basically a point of infinite density where the laws of physics just give up. Our best theories literally fall apart because they're built on this idea of a point having no size.
Now, for decades, physicists have had a really clever workaround called renormalization. It's a mathematical trick to just subtract the infinities and make the equations work. The book has this great analogy for it. It's like your ramen is way too salty, so you just add more water. Sure, you can eat it now, but you didn't actually solve the problem of why there was too much salt to begin with. It's a patch, right? Not a real solution.
So this is where the book proposes a rebellion, a full-on rebellion against Euclid's 2,000-year-old idea.
What if the problem isn't our complicated physics, but that one simple assumption we started with? What if a point isn't just an abstract idea with 0 size, but it's a real, physical thing with an actual, finite size? That is the whole argument, right there. The point has a size. And the implication of that is just profound. The author says that if you give the point a tiny, but real size, then all those infinity problems, they don't need to be subtracted or patched away. They never even appear in the first place. The whole paradox just vanishes. Okay. But an idea that big needs some serious proof. So how in the world do you test it? Well, the author's answer is a system they apparently spent 35 years of their life building. It's called OPS, which stands for the one-parameter solution. The core idea is that all the fundamental constants of nature, the speed of light, the charge of an electron, they're not just a random jumble of numbers. The author believes they're all mathematically connected in one single elegant structure. The one-parameter part means if you can find the true value for just one of them, you can use it like a key to calculate all the others. And this wasn't some weekend project. We are talking about a 35-year quest. The author was dealing with computers in the 90s that weren't fast enough, getting rejected by academics, and manually inputting and checking nearly 1 billion data points over decades. Then, in May of 2023, they claimed they had their big breakthrough, finally tying the masses of 18 fundamental particles together in one system. So that's the backstory. Now let's get to the evidence. How do you actually check if your secret code for the universe is the right one?
Well, you compare it against the official scorekeeper. This is the Particle Data Group, or PDG. You can think of them as the final word on this stuff. They're the international group that collects and verifies all the experimental data from places like the Large Hadron Collider. Their numbers are the ground truth in physics, period.
And here's the money shot. On the left is the official experimentally measured mass of the Higgs boson, straight from the PDG. And on the right, that's the value the author calculated using nothing but their theoretical OPS system. Just look at how close those numbers are. It's uncanny. And the book claims this isn't a one-off. It says they can do this for all 18 fundamental particles with the same mind-blowing precision.
So if these calculations are real, the implications are, well, they're astronomical. The book actually calls this the start of a whole new paradigm in science, K-science.
And this image, I think, captures the whole idea perfectly. On the left, you have big science, a 27-kilometer, multi-billion-dollar machine that was built just to find the Higgs boson. On the right, you have what the book calls K-science, a theoretical model that claims to calculate that same exact value using pure math. It's a proposed shift away from massive experiments and toward pure calculation.
And it's not just about academic glory. The authors see huge commercial potential here. The system they used for these calculations, the OSCS and AI-Buckingham machine, they've projected its value at over 1 trillion Korean won, which is nearly $1 billion US. So, let's be clear, the claim here isn't just about a few accurate numbers. We're talking about a whole new way to do science, one that could supposedly solve problems that have stumped geniuses for a century and unify huge fields of human knowledge, all of it based on that one single rebellious idea.
So that leaves us with the ultimate question, right? Are these incredibly precise numbers just a beautiful mathematical coincidence, a fluke that someone found after searching for 35 years? Or are we looking at the first real glimpse of the universe's source code, a blueprint that was hidden in plain sight all along? That is the billion-dollar question, and this book claims it has the answer.